Fisika. Okay, good evening. So can online student hear me?
Yes, sir.
Okay, Shinaya, thank you. So Jituli, you are joining first time, right? So Jituli is joining first time, am I correct? Okay. Shikshan. Right, let's start the class, right? So, what we have learned last week, remember? Yes, we learned elements, compounds and mixtures, yes. Element, compounds and mixtures. Right, quickly summarize the lesson, right? You can check the notes actually if you haven't in the book. Not that notebook here. So element, compound and the mixture. Elements are made out of same kind of atoms and they cannot split or break down into smaller units by non-nuclear reaction. I mean, simply they cannot break down element. It's difficult to break it down further, right? Then compounds are more than two different elements joined together chemically or combined chemically. More than two different elements combined chemically. Example, H2O, water molecule. Then mixtures are substances dissolved in solution which are not chemically bind. One second. Oh, hello. Oh. Oh. අනේ sorry මම class එකේ ඉන්නේ. Right. Then we learn separation of mixtures. So what are the methods we use? Filtration, crystallization, simple distillation. Yeah. Yes. So fractional distillation, simple distillation, crystallization and filtration. Any questions? Sure. Right. The last method we're going to learn today, separation of mixtures. Right. So before we're going to learn that method, I'm going to ask a simple question from you. Do you know name of any medicine which you have taken recent past? Muffin? Just like a muffin, okay. Panadol? Piriton? Piriton? Deslotidine. Maybe deslotidine you take for the gastritis or stomach pain? Allergic, yeah, like a Piriton like this. Right. So these are chemicals, and we also call medicine and drugs. Panadol, like things we frequently take. Anything else? Citrusine. Okay. Seos. Okay, even some I never heard of. Some of the medicines. Right. Now we are coming to the point. How these medicines are discovered, or how these medicines are first time they produced. No idea, right? No idea. Right. Penicillin. Okay, penicillin is a very famous antibiotic. So how they produced? Yeah, it was an accident discovery. So that discovery is penicillin can kill bacteria. So the person who discovered the penicillin, Dr. Alexander Fleming. Yes, Alexander Fleming. He discovered accidentally. How he discovered? Usually he grows bacteria on dish, petri dish, right? So when he grow bacteria on petri dish, so he can see bacteria. I will show maybe a video later. The completely covered on the surface. So the bacteria which is not growing here, you know, let's think like this. All of you seen gelatin, right? I mean, all of you seen gelatin. So gelatin is like, let's say, red color gelatin. So this gelatin, same thing used on this dish, we call agar. Agar is gelatin. Not much different. And let's say this surface is red color. But when bacteria grow on it, they're white color. Appears white. So he saw completely a white color when bacteria are fully grown on the surface. So the accident happened like this. He went holiday and he asked a person who's caring of the lab to take care of all the stuff that he has. And that person is not very careful. He didn't clean well, he opened the windows, because he doesn't know about these things. So after holiday, when he returned, Dr. Alexander Fleming, the plates are contaminated. Contaminated mean other bacteria, fungus or whatever around us, they are start to grow here. Because everywhere we have bacteria. On the surface, on your paper maybe, on your skin, because we have bacteria on skin. So when you touch here, so they are here. So hands, when you go public, touching the doors and everything, we have bacteria everywhere. The word used for that is ubiquitous. That means they are everywhere. Ubiquitous means they are everywhere. So then plates are contaminated, they are not very nice, they are not very uniformly white. And he noticed there is a huge mass here, like a small button-like thing, and around this there is no bacteria. So these are bacteria, white color, there's a ring, no bacteria. So when he's going to throw this one, he just saw it. So if you are very careful observer, you can make a discovery, you can find the discovery. That means he saw this one, that's observation. When he see this observation, he tried to think, what has happened? Oh, there's something here. What is this? This is a fungus. So this fungus growing here, fungus makes some chemicals. This chemical kill all the bacteria around it. So this chemical later he discovered penicillin is the first antibiotic, which helped to save the world, because when the World War started, a lot of soldiers get infected from bacterial diseases. So penicillin helped them to recover, right? So that's one discovery. Now, why we need all these things? Because most of the drugs we use nowadays, discovered from some of the sources which is written or told by some other person, a wise person. There was a wise lady living in that village, and she told, if you take this plant, it's helpful to cure this disease. So even today, scientists trying to get plant extract, and they try to find the active ingredient, maybe one chemical. Plant has 10,000 chemicals, but one chemical is responsible for the effect. Now let's come into that point. Name a plant people think this is good for this disease. Anything. Like if you take this plant, if you eat this plant, if you take this cola candle-like thing in this plant, it helps for this. Mint. For? Flu. Yeah.
So it's like anemia like a disease. Anemia is like a sort of disease.
Anemia is lack of blood.
So like spinach.
Yeah, spinach, yeah. So anemia is lack of blood. Red blood cell goes down. Red blood cell goes down. Red blood cell has a ferrous, iron. So spinach is rich in iron. So then red blood cell goes up. Yes. Asamodagang. Asamodagang is good for the stomach ache like things. Yes. Now, now coming to the point. When any mixture, let's say plant extract is a mixture. So we can get the extract. How? You just grind this, or you have a blender, you just put the leaves and put water and blend it. After blending, you filter it, then you get the extract. So, for example, gotu-kola extract, or karabincha extract, whatever, right? Then this extract has so many chemicals. Right? So let's say now asamodagang, I don't know what's it, how the English name, I have no idea, right? So you get asamodagang plant, grind it, blend it, and you have asamodagang extract. Now you want to find which chemical exactly heal the stomach ache or prevent stomach ache. The method they use globally, Japan, USA, Europe, Germany, any countries, the method is advanced or different method of chromatography. It's called chromatography, right? Chromatography. So last separation method is chromatography. I know that you have heard this one before. Class 9, I think, science book, chemistry book. Chromatography is there, right? Yeah. Chromatography is there in class 9 chemistry book. Right. Now we're going to learn a little bit more about chromatography here. So write the date. Then you write the subheading chromatography. Subheading is chromatography. So people who are new, leave one page blank. I will give this summary note. And people who are joining online, most of them, we have this workbook. So people who join a month, beginning of this month, I send this workbook to people who are joining online. And physical student, they already got this book, right? Now, any student who are joining today, new student, I send the link ebook. So you click the link, you get the ebook. At least first 50 pages you have. So then if you are continuing, I can send this book to your address. For today, exam homework questions, we're going to use ebook. The student also are joining today as online student, right? Right. Today we are going to learn very basic of chromatography, right? But don't underestimate this basic method is the massive discovery to invent the advanced chromatography method, and they still use this basic method to discover new medicines, new drugs, new chemicals. That's a practical application, right? Whatever you learn something, it has a practical application. So we can use this practical application in the future. Okay, now before we come to the chromatography method, so I just ask another question. Okay, can you describe what is this actually? Orange juice, soft drink, canned drink. So all of you like which flavor? Orange, mixed berry, mixed fruit. Right. Have you seen this Sun Crush tonic? So what is inside? Carbon dioxide to make the fizzy drink, because if you pressurize carbon dioxide gas to the water, it makes bubbles, so it makes some kind of a special taste. Water, carbon dioxide, soda, and they can add the flavor whatever to that, they make this mixture, right? So even Coca-Cola, the essence they add, water, carbon dioxide, then they have Coca-Cola like things. Now, why tonic is special? Anyone tasted this? Yeah, what taste is?
It tastes sweet first and then turns bitter.
Bitter, yeah, okay, basically bitter. It's bitter taste, right? So that's it. So next question, not related to chemistry, but what the lesson you learned before. Now, what is the disease caused by Plasmodium? Malaria, right? So Plasmodium is a parasite, protoctist, which causes the disease malaria, right? So now I'm going to show you a link between malaria and the tonic, right? So we have a small video. Can you switch on the... So there's a small video clip. We'll watch this one before we move into the chromatography method. Ooh. So, give me 1 second. Okay, done. Here, share. Okay. Oh. Right, fine. Let's have a look at this video.
So here I am on the border of the Democratic Republic of Congo and in these beautiful fever tree plantations. So the fever tree, which I'm standing next to here, is often known as the miraculous fever tree. And the reason for that is from this bark comes quinine. Now quinine is the whole reason that tonic water was invented. Quinine gives that bitterness to tonic water that those who drink it would be very familiar with. And quinine was this wonderful discovery made famous back in the 1800s when people realized that actually if you took a dose of quinine it could prevent you from catching malaria or indeed cure you from malaria. So the British gave it to their troops in India back in about the 1820s as a medicine in the morning. They mixed it with sugar, with the local fruits and water, anything to try and help the medicine go down. And that is how tonic water was invented. But the British troops also carried another thing with them, and that was a ration of gin. So they added an expedient of gin to their morning medicine with their officers' permission. And that is how gin and tonic came about.
Okay. So, do you know this logo? Oh, yes, it's a hyper Maserati, famous car, expensive car, right? Italian car. So I show you a little bit how advanced chromatography
Performance
works.
liquid chromatography is a technique in analytical chemistry used to separate, identify, and quantify each component in a mixture. As well as other forms of chromatography, in HPLC there is a mobile phase, which forced by a pump to pass through the system. And there is a stationary phase called a column, which located in an oven where the temperature can be controlled. The sample can be automatically injected into an HPLC system by the use of HPLC autosampler, or can be manually introduced into the injector using a syringe. There is also a detector attached to the HPLC system, which measures the analytes after its separation in the column.
Okay, that's end. 1, 2. Right, the video shows that a plant, I think the name of the plant is that plant is in South Africa, cinchona. This plant has a chemical called quinine. Quinine is medicine for malaria. So historically they use quinine to cure malaria. Now they have a tablet, quinine tablet, and they use tonic water for that to the people to drink. So now that's a signature or historical signature. They add a little bit of quinine, like 83 parts per million, very little, to make it a historical signature of this quinine tonic, right? And also after that you see a technique called HPLC. That's a chromatography method, right? So in chromatography method, they try to detect different chemicals, right? Now we try to learn the chromatography, right? Right. So first we take a paper. Now we call this chromatography paper. This paper could be any of the paper in your book, or A4 normal photocopy paper, or maybe if you need a better one, we can buy from a chemical shop. They call chromatography paper. They are just normal papers, right? Then second step, you make a size of the paper, you cut the paper, then using a ruler and pencil, you draw a line somewhere around 1 to 2 centimeters, okay, up. 1 to 2 centimeter up, you make a pencil drawing. Okay? That's a pencil drawing. Right. Then after that, you have a mixture. Mixture of compound. Right. So any suitable method, for example, we can use a small capillary tube, glass tube. So if you dip this glass tube, the fluid is coming into this capillary tube little bit, because we call it capillary pressure. It goes up, and then you can place it here. After that, we need a suitable jar, glass jar or something, and we keep this. For example, we just hang this like this, and then we fill this up to here with a certain liquid solution. Just 1 second. Right, and then we can close this. Then leave it. Right, so we'll do it, right? I can you draw this one under chromatography? So we label paper, a jar, solvent, mixture, and you place mixture here. Okay, so I can show you some kind of a demonstration for this. Now you see, this is a paper. Now you can see a pencil line here, just 1-2 centimeter up from the bottom margin. And I use this barbecue stick to hold this paper, right? Now, this may be the very dirty one. I just found quickly the container. So I can place this here. At the moment, I don't have something to close, but I just quickly prepare this. So you can see it is just hanging here like this, right? So what I'm going to do, I'm going to transfer here a small amount of the food coloring. So kind of 2 colorings. So I just got I think red and blue like or yellow and blue like food coloring. It's a mixture. So then I place it here. Then I'm going to add water to this container, and this is the water. Then solvent is water, and now I just dip this margin here, like the bottom line, bottom part of this, not the pencil line, just the end of this paper, the margin of this paper to the water. Then I can leave it. So I will do this, right? Then we can write the note. So to transfer the coloring, I have a small syringe to transfer it, right? So I bring the mixture. Right, here I have the mixture. So I'm not going to take a little bit to the syringe, yes. Then I'm going to place it here, small amount on the paper, yeah. So I make it bigger, like you can see it, right? So it's here, small dot. So it's not drying out, you are just yeah, so it could be okay. It's a little bit bigger. See that to visualize it, I make it a little bit bigger, right? So you can see it. Now I fill water and then just dip it, not just the line only, right? So I will add some water and let's see after that. So I add water, but somehow a little bit not the correct, because it just mixes a little bit with water, and leave it, and we'll see later what will happen, right? Right, let's start, right? Right, can you write this note for this? The method. You can write a small subheading method. Method. So we write one by one, then first step, right? Number 1. Right. Then you write cut a small piece of paper. Cut a small piece of paper. Number 2, draw a pencil line just 1 centimeter above the bottom line. Right, to the same place you can write the point number 2. Now the pencil line is considered as baseline. Pencil line is considered as baseline. Point number 3, transfer small amount of mixture onto the pencil line. Next point 4, right? Point number 4. Fill a jar with a suitable solvent. Example water or ethanol. Point number 5. Dip the chromatography paper in the solvent. Same place you can write the pencil line or baseline. Pencil line should not dip in the solvent. Because mixture can dissolve in the solvent. Right, what I told, this is not allowed. So that's a solvent. Now if you dip the pencil line and this, what will happen? The mixture dissolve in the solvent. Then the next 6 point, right? 6 point. Cover the jar and leave for some time. Last point. A pen should not be used. A pen should not be used to draw the line, because ink can interfere the result. Ink can interfere the result. So I hope you know what is pencil line, right? Pencil is made out of a mineral called graphite. Graphite is not an ink, but if you use ink, then it can interfere the result. They can also start to move here and there. Next, you write a small topic, principles of chromatography. The principle of chromatography. Principle of chromatography. Right. Some molecules dissolve in water, but some molecules are not dissolved in water. Some molecules are dissolved in ethanol-like solvent. So based on that, we can select the solvent. If water-soluble molecule, let's say the mixture has a water-soluble molecule, then we can take water as a solvent, because these are soluble in water. So some are not soluble in water, then we can use a different chemical like acetone, ethanol, methanol, like chemicals. These chemicals are dissolved in this kind of a solvent. Right? Now what will happen? So when we dip the edge of the paper, the solvent start to move up. So they can soak into the paper. Due to capillary pressure, the solvent is going up. So they can go up certain distance. The solvent is taken up by this paper. So then it's like absorb or capillary pressure, the liquid is moving up. Then when liquid is moving up, right? So here the liquid is going through this mixture, right? So now to understand the concept, let's take this example. So now two persons here, one and this is another person. So this person carry 25 kilo and this person carry 5 kilogram. So now they both start to move this direction at the same time. Right? So let's make a little bit even simple. He has only 2 kilogram. So which person can go a long distance along this line? Both the same male, both are male and both have same body mass. No exercise, no muscles, nothing, just normal. Both are same age, male, and they are just having the same kind of a body structure, mass. So which person can go more distance? Yeah, person B, because he has less mass, body mass, so he can go long distance. Now same story here. Some molecules, when they are good soluble in efficiently. So let's say we have two compounds, A and B. A is very soluble, or they are very friendly with the solvent. Then A can go more upward. B is not much soluble, less soluble. Then B can't go up because B just go a little bit. Let's say we have a C. C is not soluble at all. Then C will not go up. Because C is not soluble, it will not go up. A is very soluble, A is going up. Right? So the main principle is solubility. If the molecule is soluble with the solvent, they can go up. That's it. Right? So then this paper is called mobile phase, and the solvent is called other way around. So what is moving is solvent, that's a stationary phase, and solvent is mobile phase. Probably you have heard this from the video, if you remember, right? The solvent is moving, it's a mobile phase. The paper is stay there, stationary phase, right? Now, C stay here, A is going somewhere here, and B is going somewhere here. And that's a solvent. So that's here, here, and C is here. So solvent move up to this. And this is called solvent front. Solvent front. So solvent is going quite up. So these molecules carry with the solvent and they go certain distance based on the solubility. Right? So can you copy this diagram now? You can take just your. Yeah. Hola. right? Okay, we write the note, right? Again, point number 1. The paper is not moving. The paper is not moving. The paper is not moving. So it is, yeah, same point. So it is the stationary phase. So it is the stationary phase. Number 2, solvent is moving. Solvent is moving upward due to capillary action. Capillary action. Capillary action. So capillary action. Then the same place you can write. So it is mobile phase. It is mobile phase. Third point, if the molecules are soluble in solvent, they can move. If the molecules are soluble in solvent, they can move upward. So same point you can write. The molecule B is highly soluble. The molecule B is highly soluble and A is less soluble. Full stop, and you can write to the same place. C is not soluble at all. Right. If you want, you can use the same diagram that you already done in the picture, or you can make a separate diagram. Then we take a ruler. So we place the ruler to the pencil line here. So that's a 60. Yeah, to the pencil line, and we measure the distance using a ruler. Let's say the distance is x centimeter. Just write it here. So I write it here, x centimeter is the distance from the baseline to the solvent front. Then I take again ruler, I measure the distance from baseline to B. So y centimeter, and I measure from here to A. So Z centimeter. So baseline to the solvent front, that's the first measurement. Baseline to the molecule B, baseline to molecule A, using a ruler, right? Then I'm going to calculate you want to draw this. Okay, it's up to you. If you want to make a new picture, so then you can, you don't want to write all these things now. If you make a new picture, no point of writing all these things, because you have done, only you need the values. Or you can use the previous picture. If you have a space, it is not crowded, you can add these values. So still we can label that's the baseline, and that's the solvent front. Jesus. Right, done? Now we have a small calculation. So this calculation value is called retention factor, or RF value. So we write capital R and simple F, just right here, capital R and simple F, like this, subscript, yeah. Just a subscript F, just beneath the R, we write F, retention factor. Right.
Sir, we can tell that as retardation factor also. No?
Retardation factor. Retardation and retention. So I think literally both are same meaning. Retardation mean, retention mean what is cheap. Retention, if you have money, you spend 100 rupees and you had 1,000 rupees, you spend 900. What is retention is 100. Like what is left, like retardation or retention. But this is the word used. But anyway, the word used actually RF. Some people, they don't know what is it even. So the word usually RF value use, because 99.9 people, they don't know certain tag. For example, everybody knows what is pH, but they don't know what is the meaning of P and H. That's a potential of hydrogen ion, the abbreviation for potential of hydrogen ion. So likewise, some of the words actually we don't use anymore, like even a very common like a DNA molecule, we just use DNA and RNA. We don't write the names, big names. You get the marks, right? So now how we calculate? First, we measure the distance traveled by the solvent front. Distance traveled by solvent front. And here, distance traveled by the molecule B. So I give one example, distance traveled by the solvent front X and distance traveled by the B is Y. So then the centimeter and centimeter, so we can cut, and it is just giving a value without a unit. So this value, so Y divided by X is the value. So that's the value, we get a small number 0.5 or 0.8 like this. Decimal value we get always as a RF value. That's a calculation. So can you complete the note by doing this calculation? Okay, as on the verb X, right, so we can see this. So if you look at, we can see the solvent front, the water line is up, and this one try to go a little bit up, but that's not, it's not really good, this setup. We need a proper way to handle do this, but still we can see the water line is somewhere here. I think you can see, right, water line? That's a solvent front, and that doesn't dissolve much here. Otherwise, you can see the dye and everything is going up. That's just a small work to get an idea, right? How it works. Okay, we're going to recap again this method by an animation, right? So then just going to your mind and you remember it. Okay. Boys. Right, last week we also watched this one, all the videos, how they're doing a crystallization, filtration, fractional distillation and simple distillation. Now, same way, the last one, chromatography, we're going to learn. Switched on, right? Right, let's start. So, crystallization, last week we watched how it's doing. And we also learned simple distillation. And last week we also learned fractional distillation. Now we are coming to the chromatography.
Roger, Major. This is Modern Talking Space. Roger.
Yes.
78789. 78789.
That the program is not just masking.
Spaceship 1998.
The bottom line is cut down this bar, right? Okay, now here you see using a pencil we can draw a line.
We are now 10 seconds from countdown. 10, 9, 8, 7.
So they do it here 4 centimeter up.
4, 3,
That's a capillary tube.
1.
So we can take the capillary tube and dip in the mixture. That's a red and blue ink. And then transfer exactly onto the spot label P or whatever. So if you want a little bit more, you can transfer to the same place a little bit more.
Right here on the station that pays. If you want the hits, the whole hits, and nothing but the hits. On your FM dial, keep it right here, baby. Modern Talking. Cherry lady. And it goes down.
And now we can take the distilled water. That's the jar, and pour the water to the jar, cover it up. But they also use alcohol. So another one that's actually water and alcohol is ethanol mixed ethanols, diluted ethanol. Mix it. So if you say ethanol like thing, we have to cover it up, otherwise evaporate quickly. Now you see we dip it, not the pencil lines, and then cover it and leave it for some times. The time is passing and the solvent front is going up. With the solvent front, the molecules also going up. Right, then you take it out, leave it to dry, and then you can see a solvent front, and then you can also see two separated dye, blue and red one. So solvent front is 15 centimeter. So then the line P 13.2 centimeter, then RF value is distance traveled by the solvent from, divide by this, you get this RF value. So what is this place? Okay. That's end. Done. Now, we're going to do some questions from the book. So, the student join online today and they don't have a book, just click the link sent to the WhatsApp and you get this ebook. So, when you get the ebook, you can go to the page number 22. Go to the page number 22. The question is about the separation of mixtures. The table shows some methods used to separate mixtures. Place a tick in one box in each row of the table to show the best method of separation for each mixture. So we have a chromatography, simple distillation, filtration and fractional distillation. And PQRS is the separation method. So let's try. So give it a try. The first one is red ink from a mixture of colored ink. Separation of colored inks. Next method, ethanol from a mixture of ethanol and water. Ethanol and water. Sand from mixture of sand and water. Water from copper sulfate solution. Yeah. Wow. Right, let's look at the answers for the question number 5. A1. Today we have learned the red and blue color like dyes separate. We can separate by chromatography. So P, chromatography. Chromatography. Then ethanol and the water. Both are liquid, both are colorless, both are dissolved in same solution. But we learn one thing, they have a different boiling point. So water boiling point is 100, ethanol boiling point is 78. So if we heat up to 78, ethanol is going out first. That's called fractional distillation. So fractional distillation. Sand from mixture of sand and water. So that's very easy. We have to filter, right? So sand and water we have to filter, and the sand in the filter, water is going down. Then water from copper sulfate solution. So it's something like a salt dissolved in water. If you evaporate water, salt stay. the copper sulfate is same, then we can do for this one simple distillation. Simple distillation, water evaporate, copper sulfate stay. Okay, those who done, can you do question number B? Pure dry crystals of magnesium nitrate can be obtained from magnesium nitrate solution by crystallization. So crystallization is again a little bit same. We just boil, water evaporate and crystal stay. Okay, I didn't see. Which of the, sorry, there's another question, right? Which of the mixtures PQRS contain an undissolved solid? Yeah, sand. Sand. Sand is not dissolved. Sand is not dissolved. These steps describe the method, but the steps are in the wrong order. So crystallization is the method we used to separate solid when they dissolve in the water. I think we have learned it many times. Even from the beginning we have learned potassium nitrate, solubility we learn, and for that the best thing is we should have a beaker filled with water, and we can keep this evaporation basin here. This is the solution, and we can use a Bunsen burner to heat this. CAD, CAD. Okay, let's see the answer for this question, right? Now, basically what we have to do, we have to evaporate water until crystals form. Because crystals are solid, copper sulfate or whatever, and they stay here. So we learn from the solubility experiment and before experiment, best way is we use a beaker filled with water and the Bunsen burner. So when the water start to boil, the heat distribute equally. Otherwise, if we directly place the Bunsen burner to this place, there's a chance when crystal forms, crystals can damage, or water is not unequal, the water bubbles can go out, like many things can happen. That's the best way, and the water evaporate. So then the first one is heat the solution to evaporate some of the water. Heat the solution to evaporate the water. Then already given the next step, dip a glass rod into the solution to see if crystals form. So then when the water is evaporated at one point, then we can use glass rod to check whether crystals are formed. Then next step, we keep this out because it's still very warm and the crystals are also warm. We just leave them to cool it down. So then the next step is A, B, E, A. And here they have a small difference because our videos we see until they completely leave it crystals form, all the water evaporate. But here this method, then there is some water left because of that for the mixture of crystals and solution through filter paper. So we have to use filtration as well now. So that's a filter paper, and we placed this to the filter paper. After that, all the water is going out, and we can keep the crystals to dry. That is D. Put the crystals in a warm place to dry. So B, E, A, C, and D. Okay, we do a question number 6 as well. That's about the chromatography. A student uses this apparatus to investigate the dyes in food coloring. Chromatography paper, water used as solvent, and baseline drawn in ink. Explain 2 mistakes that the student makes when setting up the apparatus. So today you learn this method, but the student made a mistake here. So identify the mistake and write why mistake makes problems in this setup. Identify the 2 mistakes and write it down. Explain why these mistakes are very bad.
So he's setting it up or he's already doing it?
He's going to do this one. Now when he's going to do this one, we can see at one stage how it looks like.
Yeah, so like, is he setting it up or is it in the middle of the process?
Let's consider middle of the process because the picture is in the middle of the process. Then you have to measure the RF values like things, no? So we consider that's somewhere middle of the process. We see it like this. Right, let's look at the answer, right? Now, you need to get 4 marks. Consider the command word of the question, explain. So usually this word, when you have in the question, it says what you see and why is that. The answer is that, usually answer for explain question, what you see. Then you write what you see. That's a very easy one because you can easily see things. Why it is happening, you have to think. So what effect it has, that's the explanation. Right? Okay, now some student focus on kind of a little bit of away from the main content. For example, if you look at, it doesn't have a jar, lid to cover the jar. So if you go like that way, okay, no lid, explanation is water will evaporate. So you think 1 mark is no lid, 1 mark is water will evaporate. You don't get marks. Because that has not much effect. I mean, I also didn't cover this one today. Like just for 10 minutes, 15 minutes, just finished. So water will, if you boil the water, water will evaporate. Now some student will say, oh, there is something not hanging up here, there is to hang up. So that will go down. That's also not the main focus because it has a too obvious thing that's extremely wrong. You have to find that one. Right? So one is, I told you beginning, should not use pen or ink. The student use here ink. The baseline has been drawn in ink. What you see is the baseline has been drawn in ink. That's what you see. And the explanation is, so that will interfere the result because this ink will also diffused. Then it masks the experiment result. So it can interfere the result or it can affect the result. That's the first thing, right? That's true. We should use pencil, not ink, because ink can dissolve in water and then it can make some problem, right? Then the second one, he dipped the baseline or the A inside the water. That's also wrong. The baseline is baseline or molecule A, the mixture A is inside the water now. Explanation is they dissolve in water. They dissolve in water. So then the sample will dissolve, sample will not go up, there's not enough sample, they dissolve in. Now the first point is the baseline has been drawn in ink. Explanation that it can interfere the result. Now they dip the baseline in water, then they can dissolve in water rather going up. Okay. Next, the student repeat the experiment but with no mistakes. So this time he did correctly. The table shows the RF values for the 2 dyes food coloring A, blue and yellow. Complete the chromatogram for food coloring A by adding and labeling the dyes. So you have to complete the chromatogram by adding A and B, blue and yellow correctly. here A. Blue is 0.50. Yellow is 0.25. Show it 2 dots and write the name of the 2 dots.
So like only blue and yellow, right?
Yeah, the two dye in this A is a mixture. A has blue and A has yellow. So you have to show here the distance. You write in a pen, right? Next time. Right, one advice I can give you, right? Use the pencils to do it, because if you made a mistake, you can erase. So in exam, you don't have a Tipex or whatever, you can't use anything. So if mistake happen, you can't erase, then you have to cut. So it make a mess here at the end, so then there's a chance of not getting marks. So use a pencil for this kind of thing. Now, after using pencil, if you think confident, okay, now it's the correct one, you can write over it with the pen, a black pen. You should use a black pen to write answers. Why is that?
Because of the scanning thing.
This guy knows everything. How do you know? Yeah, you know everything, right? Yes. Now, how it works? When you write in a black pen, the papers securely, original papers keep by the Pearson Edexcel, and usually it's like this. British Council is responsible for the all exam in Sri Lanka. So they get the paper from UK, they distribute the paper, they check everything is going well, papers are not leaking, or they are doing properly, not cheating, like thing, all they check. Then they collect the papers, so collection done by private centers or schools, and they send to the British Council. British Council send everything back to the UK. In UK, Pearson Edexcel, they scan the papers. After scanning, these papers they keep securely there in a special place, not lost, not damaged, no floods, no earthquake, like anything can happen. And the scanned copy, they have a database. I mean, they scan copies they keep in a network somewhere in the servers, and scanned copies they send to the examiners. So examiners use the computer to check the papers, and they give marks on the paper by giving some kind of a software they use to give marks. So if you make a mess, then the scan copy say this is your line, the graph like things. So all the lines visible. Then it's difficult examiner to judge which one is correct. So that's why certain things we need a pencil, right? Now, let's see answer. Now there's a problem. So RF value, so this RF value, the solvent front, I just write solvent front, and the dye distance, right? So we calculate like this. Now we need to have at least some idea about the solvent front. So here no clue. So then you just, okay, shoot the solvent front here, solvent front here, solvent front here, solvent front here. Where is the solvent front? So we need to make a wise guess about the solvent front. Let's make a wise guess. Where is the solvent front? Which place you're going to take as solvent front? That's baseline is okay. Solvent front. Make a wise guess. The solvent front. Below the baseline mean here? No. The solvent front, what is, the solvent is going up. The solvent front is solvent which is going up.
One third of the height of the
double the distance.
Yeah, double mean, so let's say blue. So let's make this assumption, RF value for blue, solvent front we measure as a 10 centimeter and the other one is measured as a 5 centimeter. So if you do like this, the value is 0.5. That means you call double. The solvent front is double. That's why solvent front is double, right? Now the solvent front is double. Where we can keep the solvent front? Yeah, there is a small problem. Even the questions, this one they haven't given us solvent front. And they didn't ask draw the solvent front. If they ask draw the solvent front, you can make it easy. Okay, you make a line here, just write solvent front is this. If the solvent front is this, the halfway here is the blue one. Then it's correct. But here they didn't ask to draw the solvent front. Then we have to find a place, proper place for the solvent front. So with the practice and this kind of a difficulties, you are starting from the beginning, but if you go 2 years of this journey, then because of the practice, exam practice questions, and you do more practice and practice, you're going to decide, okay, solvent front is this, the top level. So you can take the top level as a solvent front. And if you take the top level exactly in the middle, somewhere here, 0.5 then you make a line here and then you can write blue. And 0.25 is a quarter of this. Quarter of this means, so if we divide this is the solvent front. That's a half and quarter is here. So that is a yellow. That's a yellow. So if you have approximate picture like this, you get a marks, like not exactly measuring 0.5, 0.25. So if you have a blue up and 50% of this up and 25% of this, that's okay, right? So if you made a mistake, like if you draw blue like this, the yellow one is here, then that's not correct, right? Yellow one should be quarter of this then. Give a reason why the blue dye has a larger RF value than the yellow dye. Blue dye has this one has a large RF value. It is soluble, yeah. It has, it is more soluble, yeah. It's more soluble. Blue dye is more soluble. And some of them I notice, if you try to write too much, the space given, right? So when you write 2 hours the paper, you have more additional thing. That's also a little bit problem, because remember, don't write too much, don't write too less. You will learn with the time what extent you have, because if you write too much, time management is difficult. because 2 hours you can't write too much. So my idea is if you have 3 lines, maximum 2 lines is okay. So if you have 4 lines, then the 3 lines like that. You can write the best answer. You don't write complete area to get the full marks. So to 70%, fill in the area given, that you can write a good answer. We can quickly do 7 as well, right? Question number 7. Can you do question number 7A? 7A. So 7A, if you done, we discussed only that one, right? What's the difference between compound and molecule?
Molecule is 2 or more same element but 2 or more particles.
Compound is like 2 or more elements chemically joined together in equal ratios, whereas molecule is like 2 or 3 elements joined together not like chemically.
Okay, ratios. So let's make it simple then, right? The molecule has same or different element. 2 different element. Same or different, 2 different elements. More than 2 different elements. Compound only has 2 or more different element, different, same. So the word we use only, we say different and same or different element, same or different element. Here only different. Here only different. For example, oxygen, same molecule, oxygen molecule. Oxygen molecule, it has only same, right? So compound, they have 2 different elements. Compound has 2 different elements, but molecule has same or different. That means everything is molecule. We can consider all are molecule. All are molecule because it come under same or different category. But this only come under different, not same. Because we don't say oxygen compound, right? We don't say a chlorine compound, chlorine molecule, right? So then the answer is, which of these is the formula of a molecule of an element? So oxygen atom is here. First one is oxygen atom, and hydrogen chloride, different element. H2O, different element. So chlorine has same element. Chlorine is the answer, Cl2. Answer is Cl2. Next question is also very easy one. B. So you can also do next question, is easy. Which method can be used to separate insoluble solid from a liquid? Solid, Yeah, sand dissolved in water use filtration. Answer is filtration C. Next question is also easy C. Give the name of the method used to separate mixture of liquid from different boiling points. Fractional distillation. Different boiling point fractional distillation. So ethanol 78, water 100. So ethanol evaporate at 78, water evaporate at 100. Okay, now note it down, the homework you should do. So we can complete this one, right? This question we can complete. A student add a crystal of substance X to some water in a beaker and leave the beaker for 1 day. The diagram shows the beaker immediately after adding crystal and after 1 day. So 2 beakers, crystal added and leave 1 day. So crystal disappear. So after 1 day, no more crystal. What happened to the crystals? Dissolved. They dissolve because they're soluble, right? Which equation gives the correct state symbol for the process that occurs in the beaker? So I will give again. So if we have a solid, we write simple S, gas simple G, liquid simple L, and anything soluble in a liquid we call aqueous, AQ, aqueous. So if we add that is soluble in solvent, we call aqueous. So gas, liquid and solid is states of matter, and if we dissolve a solid in liquid and it is soluble, we call aqueous. So answer is D. Answer is D. Which other process occurs in the beaker? Yes, the particles diffused. So particle diffused. The color is then equal, uniform color we can see because they diffused. Next part leave it because we have to learn a little bit more to understand that, because we need a special flame test and addition of acid, the barium chloride solution, what happened like. So these things we're going to learn in the future. So that part you leave it. So we haven't learned this. So we're going to learn in the next coming up lesson. And as a homework, can you do question 8, 9, 10? 8, 9, 10. 3 questions. So 8, 9, 10. 8, 9 and 10. Right, that's all for today's, and do the homework for next week. We're going to start a new lesson, the structure of the atom. Next week we're going to start structure of the atom and periodic table. So see you again next week, and good night.
Go,